Good day, learners. Welcome to another lesson on investigating angles in quadrilaterals. Did you know that the kite that the children play with on a windy day will fly higher depending on the size of its sides and angles? Our lesson objectives: by the end of the lesson, you should be able to identify and write clear definitions of quadrilaterals in terms of their sides and angles. The next one is to investigate sides and angles of quadrilaterals, focusing on, firstly, the sum of the interior angles of quadrilaterals, and secondly, the sides and opposite angles of parallelograms. Our concept map for today will be, firstly, to identify and define quads, then the sum of interior angles, and then we move to sides and opposite angles. What you should know is how to describe, to sort, name, or compare triangles according to their sides and angles, focusing on the equilateral triangles, isosceles triangles, and right-angled triangles. Let's look at pre-knowledge practice, question 1. In triangle DEF, the sides are marked as on that diagram. EF equals to 10 centimeters. That's what we are informed. What is the name of the triangle? We look at the markings. All sides are equal because there's only a similar mark on all the sides. And with those three sides equal, it is an equilateral. So that is the name, equilateral triangle. Equilateral triangle. And then calculate the value of angle D. Already we know that if it's an equilateral triangle, that means all three angles are equal to each other, and when added together, they are equal to 180. So that means all three angles would be equal to 180 divided by 3, because they are all equal, and that would mean 60 degrees each. So angle D is 60 degrees. What is the length of DF? We go back to the question. The question said EF is 10 centimeters, and the marking says it's an equilateral, all the sides are equal. Therefore, DF is also equal to 10 centimeters. Let's move on. In triangle GHI, angle G equals to angle J, and equals to 22 degrees, and GH equals to 7 centimeters. Let me write it so that you can see it. There's 7 centimeters. That's not 7. Yes, 7 centimeters. Angle G equals to 22 degrees. Angle J also equals to 22 degrees. And then we are asked to determine the size of angle H. We know that angles of a triangle, the sum of the angles of the triangle equals to 180. So angle H, 2 degrees plus 22 degrees equals to 180, because of the sum of the angles of a triangle equals to 180. And therefore, that means angle H would be given by 180 minus 44 degrees. 180 degrees minus 44 degrees, and therefore H would be given by 136 degrees. That is our angle there of H. Almost forgot. Always put an indicator that this is an angle. Okay, the reason for number A is sum of angles of a triangle equals to 180. So it was missing that 180. Okay, and then we continue labeling our triangle, and now we are to determine HJ. Already, if we have an angle on angle G and angle AJ and they are equal, that means this triangle would then be an isosceles triangle, because the two angles that are equal would also have opposite them the sides that are equal. So side HJ equals to 7 centimeters as well. And of course, we had already said it is an isosceles triangle. Isosceles triangle. Why do we say that? Because the sides opposite, the angles opposite the equal sides are equal. Angles opposite equal sides are equal. Don't forget to always put a reason with your statement to show your understanding of the work that you're doing. Number 3, triangle PQR is a right angled triangle with R equals to 42, angle R equals to 42 degrees. Calculate the size of angle P. Angles of a triangle equals to 180. So it's going to be angle P plus 90 degrees plus 42 degrees, which equals to 180. And that is the sum of angles of a triangle equals 180 degrees. And therefore, it's going to be angle P plus 132 degrees equals to 180. And therefore, angle P equals to 180 minus 132 degrees. And therefore, angle P equals to 48 degrees. Words that we are going to maybe hear for the first time or going to use in this lesson. The first one is a vertex. A vertex is the point at which two straight lines meet to form an angle. In these examples, we're going to see that as where two lines meet, that becomes the vertex, where they form an angle. But then I've used the door as an example so that you would be able to see that the door is open at a certain angle, which means there is a space there that forms an angle, and the doorway becomes the vertex. Our next word is quadrilateral. The figure that has 4 straight lines joined together to form 4 vertices. And the picture on the right, I've used chalkboard, which would have 4 sides, and all those 4 sides are joined together at the corners, and those are our vertices. So there are 4 vertices that are joining 4 different lines of the chalkboard, and that is then a quadrilateral, a figure that has 4 straight lines. And then a diagonal is a line joining one vertex of a polygon to a non-adjacent vertex. Remember, adjacent means they are next to each other, and this one is non-adjacent, so you are joining one from the top. Let's draw a quad, and in that quad we then have a diagonal that will start from one side to the other, touching sides that are non-adjacent, which are not close to one another. And as you can see, it's there ending where the other 2 sides are adjacent and we're coming from the other side. An example of that, I've put a beauty pageant belt, which starts from the right shoulder down to the left-hand side of the body. So that would be a diagonal. That's how a diagonal line appears. Let's stop there for now and go for an ad break. See you soon.